Can you see my Canvas webpage now?
Yes.
I want to make sure that I have the right screen shown to you while I'm talking. That's why I'm asking questions. We finished chapter 1 and 2. Now we're going into chapter 3 and 4. We build our chemistry knowledge based on what we learn on chapter 1 and 2 and move on to chapter 3 and 4. When you click on chapter 3 and 4, chapter 3 is on chemical bonds. You can see it here. Chapter 3 is on chemical bonds. Chapter 4 is on chemical reaction and energy. So I am going to go to PowerPoint slide and start the chapter 3 now. Do you guys have any questions? Do you guys have any questions? Can you hear me?
No.
All right. I'm going to go to chapter 3 then. Can you see my PowerPoint slide first page? CHEM 1054.
Yes.
All right. I want to make sure that we are on the right page. As we discuss, next in the calendar, next test number 2, is going to be on October, probably October 9, somewhere in that time frame. So we will get ready for chapter 3 and 4. It says 3 and 5, we only cover 3 and 4. Okay. So I am going to go to chemical bonds. I want to get this out of the way. Chemical reactivity or formation of chemical bond are based on the idea that atoms of elements react to gain an octet to valence electrons. That's called octet rule. There are 2 ways to get octet to and valence shell. One is losing whatever electrons they have to form cations, or other way is to gain electrons. Normally metals lose electrons to make cations. Non-metals gain electrons to make anions. So we're going to look into how the anions and cations form are named. There's another way to gain an octet of electrons. One way is ionic bond. Ionic bond is losing electrons to a nonmetal and cation and anion formation that has ionic bonds formed. So naming ionic compounds also part of the chapter 3. Covalent bond is, on the other hand, is formed by sharing electrons between 2 atoms. It's a different idea than ionic bond. Ionic bond transfer electrons from metal to non-metal. Covalent bond share electrons. We also have to know how to name covalent compounds. Naming ionic bonds and naming binary covalent bonds are different. Covalent compounds also show structures, bonds. There are different arrangements for bonds in a covalent molecule. That's the idea about resonance. We're going to look into that in detail as we go deep into the topics. Covalent compounds form molecules. Molecules have structures, unlike ionic compounds. Ions don't have a structure. Ions are just similar to atoms, except they have more electrons or less electrons. But covalent compounds have atoms bonded to each other. They have bond angles. So we have to come up with a way to predict how the bond angles are different for different covalent molecules. So we can predict bond angles in covalent compounds. We don't do that for ionic compounds. Covalent compounds also, which are molecules, neutral molecules, they also show something called polarity. So you have to be able to tell, if I gave you a covalent compound, molecule of a covalent compound, whether that molecule is polar or non-polar. Those are the topics that we're going to talk in this chapter 3. This is mainly based on octet rule. Okay, instructional objectives. I'm not going to talk about them right now, but we will come back and look into them. These are the titles of instructional objective subsections. So we're going to get into octet rule right away. Octet rule and predicting chemical reactivity of elements. That's a subsection. Lewis came with the idea for chemical reactivity. He proposed a model for bonding. He based this idea on noble gases, which lack chemical reactivity. They are stable. They have stable electronic configurations. If you look at noble gases, last column on the right of the periodic table, helium, neon, argon, krypton, xenon, radon, they all have octet of electrons except the helium. They all have octet. Helium is in the group, noble gas group, in the period 1. Period 1 can have only 2 elements, hydrogen and helium. Therefore, helium cannot have 2 electrons other than 2 electrons. It cannot have 8 electrons. So this idea, noble gas show stability because of they have 8 electrons in their valence shell, is the Lewis model, octet group. So we're going to look into main groups element. I'm going to show what main groups are. His rule applies only to main group elements. They achieve electronic configuration of 8 valence electrons to become stable. Otherwise, they are reactive. An atom can lose 1 or more electrons and become a cation or positively charged ion. That is metals. Non-metals gain electrons to become negatively charged, and negatively charged ions are called anions. These first two are how the ionic bond is formed. This last one is sharing electron. Is the way octet is achieved by other elements in the periodic table other than noble gases. So this applies only to group 1A, 2A, 3A, 4A, 5A, 7A. We don't talk about 8A. 8A is noble gas. Let me show you these groups, main groups in the periodic table. Can you hear me? Are you guys can hear me?
Yes.
Okay, I'm just. Do you see the periodic table? Do you see a periodic table
Yes.
on your? Okay.
Yeah, we do.
Okay. 1A is here. 2A is here. 3A is here. 4A is here. 5A is here. 6A is here. 7A is here. These are the main groups. Main groups are the tall groups in the periodic table, including S block and the P block, except the noble gases. Octet rule doesn't apply to transition metals, which are B groups. Can you see B groups here? I'm underlining it. So octet rule also don't apply to lanthanide and actinides, bottom, 2 rows. Therefore, octet rule is applicable to only main group elements. Let's look at how a cation is formed to satisfy octet rule. Sodium atom lose an electron to form sodium ion. Sodium electronic configuration is here. The valence shell is third shell. That's the outermost shell, third shell, number 3. So its Lewis dot symbol is this. This idea about Lewis dot symbol, Lewis came up with Lewis dot symbol even before we knew about the electronic configuration. Therefore, that is leap in the knowledge before we really figure out what there is leading to Lewis dot symbol. So sodium loses 1 electron and it becomes that electronic configuration. That is neon. Metals loses electrons and form the octet of preceding. Preceding means before sodium. Neon is before sodium, one place before. So cations lose electrons and get the electronic configuration of preceding noble gas. On the other hand, anions gain electrons, 1 or more electrons. For example, chlorine is gaining 1 electron. Chlorine has incomplete octet here. it shows in the missing dot here. So it gain an electron and complete the octet of electron. Non-metals gain. You guys have a question? Argon electron configuration, succeeding electronic configuration. Now there are exceptions to this octet rule. It mainly applied to main group elements, as I indicated, 1A, 2A, 3A, 4A, 5A, 6A, 7A. But when it applies to highly charged ions, highly charged ion is metal with 4 plus, or non-metals with -4. So for highly charged ions, it doesn't apply. Group 1A and 2A, this is okay. Group 1A forms 1 plus. Therefore, highly charged ions tend to make unstable cations. Therefore, it doesn't happen. Anions also, like I talk about, it's easy to gain 1 or 2 electrons, but to gain more than 2 electrons, like carbon -4 or carbon +4, losing electron, are difficult. I also talk about transition metals and lanthanide and actinide. For these elements, octet rule doesn't apply. They have d orbitals and f orbitals. It complicated the picture. Octet rule only apply to s block and p block elements, which are main groups elements. Which of the following element is listed number of valence electrons are correct? These are the lists. When you look at, I wrote down the group number, went into periodic table. If the group number is same as valence electron, that's correct. This is incorrect. This is incorrect. Valence electron has to be 4. Therefore, correct answer is A. Which of the following elements would have Lewis dot symbol that contains 5 electrons? If atom contains 5 valence electrons, it must be in a 5A group, nitrogen group. So nitrogen is 5A. Phosphorus is also in the same group below nitrogen. Therefore, these two have 5 electrons. This has 7 electrons. Therefore, answer should be both A and D. That's how you get the valence electron configuration, valence electron numbers. Now, sometimes we list group numbers in different form with Roman numeral here, normal number, or just without letters, 15 or so, represent group 5A. Group 5A has 5 valence electrons. Choose the appropriate number of valence electrons present for the response. How many valence electrons this has? valence electron. It has to be 5. 1 valence electron. It's not an 1A. That's wrong answer. 3A. That's not correct. This one is 5A. That's the correct answer. 7A has 7 valence electrons. For the group 5A, there are 5 valence electrons. Answer is C. Now we look into periodic table, and you knew I am marking the main group 2A, 1A, 2A. For example, when they lose 1A, elements lose 1 electron and make a positive 1. They make positive 2. Aluminum never lose 3 electrons. Boron never lose 3 electrons, but they may lose 3 electrons. When it become, that's 3 valence electron, 4. When it come to 4, they will never lose 4 electrons. Therefore, they make covalent bonds. The larger the number of valence electrons, they make anions. Smaller the number, 1 and 2, plus 1 and 2, they make cations, 1 plus and 2 plus. Which is most likely to be true of atom with 6 valence electrons? If an atom has 6 valence electrons, it's greater than 4. Greater than 4. This is less than 4. That doesn't lose. This is the one that applies. This is less than 4. Greater than 4. This is greater. This is less. If the valence electron number is less than 4, they become cations. If greater, this is 6. 6 is greater. They will gain. How many electrons they will gain? 2. Therefore, it will gain 2 electrons. That's the correct answer. If there are 6 valence electrons, they will make an ion, gain electrons, 2 electrons exactly. Answer is B. Same idea. What is most likely to be true of an atom with 1 valence electron? It's less than 4. It will lose. How many electrons it will lose? It got only 1. Therefore, it will lose 1 electron. None of these are true statements. Therefore, answer is C. Now we're going to look into a few more examples. 1A has 1A is same as group 1, 7A as group 17. This has 1 valence electron, this has 7 valence electron. If something has 1 valence electron, they make positive 1 charged species. If it's greater than 4, 7 is greater than 4, they gain 1 electron, become negative. So this one become a positive ion, positive 1 ion. This become a negative 1 ion, negative 1 and positive 1. Answer should be negative 1 and positive 1 and negative 1. Positive 1 and negative 1 is this choice. Therefore, answer is D. These are the main groups I shown you in the periodic table. They, to make him bond, they do lose, gain, share to achieve electron configuration of a noble gas. So answer is lose, gain, share electrons. We're going to look into a few more examples of chemical bond formation. According to Lewis' model, ionic bond is formed by losing or gaining electrons to form cations and anions. Ionic bond is the result of attraction between cations and anions. Covalent bond is, on the other hand, result from force created by share one or more electron pairs. So there's no charge transfer like cations and anions formation in the covalent bond. So there are two major types of chemical bond based on octet rule called ionic bond and covalent bond. In forming sodium chloride, one electron is transferred from sodium to the chlorine atom. This is the sodium electronic configuration. That's the chloride. So chloride, sodium become neon. This become argon. Both has 8 electrons. The attraction between sodium ion and chloride ion is the formation of ionic compound. You can show electron transfer from here to here. This becomes 6, this becomes 1 less. 1 less is gone. So that's how you describe formation of ionic compound. Or Lewis dot structures. This electron is going to chlorine. Chlorine has octet of electron. This also have octet of electron represented by the preceding noble gas, neon. Do you guys have questions? You guys still hear me? Can you guys hear me?
Yeah, now okay.
Okay. Octet rule and electron sharing, covalent compounds. In sharing electron, oxygen and nitrogen and carbon, all of which are nonmetals, they form a molecule. For example, 2 hydrogen and 1 oxygen share these electrons and form an octet to oxygen. Therefore, bonds, 2 chemical bonds are formed here. The non-shared electron pairs are called lone pairs. So we're going to describe more in detail. So nonmetals share electrons to form covalent compounds. Metals and nonmetals transfer electron to form cations and anions. That's a different description. These are non-metals, hydrogen non-metal, nitrogen non-metal. Nitrogen has 3 unpaired electrons. Each is paired up with hydrogen 1 electron. Then nitrogen has octet, duet for the hydrogen. Hydrogen is like helium, cannot have octet. So basically hydrogen becomes noble gas equivalent to helium. So in methane, natural gas, carbon has 4 valence electron. It shares with 4 hydrogens and produce octet for the hydrogen and duet for the duet is same as helium. Hydrogen has duet. So therefore stable octet rule is achieved. This is the two-way ionic bond, covalent bond, how the elements react to form compounds. Which pair of elements will form ionic compound, anionic compound? We already talked about ionic bond formation in non-metal, metal, non-metal. That should be the answer. Non-metal forms covalent bond. Metal with the metal make metallic bond. That's a different issue. Semi-metals have this. Semi-metals are very close to non-metals. They are half non-metals. Therefore, they don't make ionic bonds. So only pair of elements that form ionic bond is metal and non-metal. Answer is C. Which pair of species is most likely to form an ionic bond? 2 electrically neutral species? No, that's false. 2 oppositely charged? That's correct. Cation and anion. 2 negatively charged species, they repel each other. Or 2 positively charged, these two are wrong. Ionic bond is formed by 2 oppositely charged cation and species, which are cation and anion. Answer is B. And covalent bond is not associated with which of the following? Covalent bond is not associated with transfer of electron. Transfer of electron forms cation and anion. Therefore, this interaction of valence electron happens in the covalent bond. Equal sharing is electron happens. We're going to look into covalent bond and show what covalent bonds equally share and unequally sharing covalent bond. These are all 3 possibilities of covalent bond. But this is not associated with covalent bond. That should be the correct answer. D should be the correct answer. I'm showing again periodic table. Main idea is main groups. There are 7 columns. Each one has same number of valence electron as the group number 5A, 6A, 7A. So it's easy to predict bonding pattern from the periodic table. Now, we're going to explain a little bit more about how ionic bonds are formed or covalent bonds are formed between 2 elements. The idea Linus Pauling came up with is electronegativity. It has been used to predict whether atom form two atoms will make a bond between two elements. Bonding going to be ionic or covalent. Electronegativity is number which represent the attraction of electrons in the valence shell. Attraction of valence shell electron are related to ionization. We talked about atomic sizes and ionization energy in chapter 2. Pauling came with a scale with following electronegativity values. Highest electronegativity, most attraction to valence electron is the flow rate. There's a trend in the periodic table. In a group, going top to bottom or going down, that's the increasing order. That is the decreasing order. We don't have to show that. That's the increasing order of electronegativity. If you look at the values, 2.1, 1.0, 1.5, it increases this way. It increases this way. So if you have to decide between bond between sodium and chlorine, you have to take the electronegativity difference. Chlorine is 3.5. Sodium is 0.9. Minus 0.9. You get 2.1. The difference 3.0 minus 0.9 is 2.1. So we exactly say what difference, electronegativity difference, give rise to whether ionic bond or covalent bond. Let's look at it. One way to predict whether bond is ionic or is to use electronegativity difference. Like I said in the previous slide, non-metal, for example, chloride, electronegativity difference is 3.0 minus 0.9 is 2.1. So there are exact values. If that difference is greater than 1.9, that's the ionic bond. Lose or gain electrons. If that difference is between 0 and 0.5, that's the covalent bond shared equally between two atoms. If it is between 0.5 and less than 0.19, that's a polar covalent bond. So we can predict type of bond based on the electronegativity values. Covalent bond is associated with the following: What is associated with covalent bond? Sharing electrons. It doesn't include this. There are no interaction between two nuclei. Transfer of the electron is ionic bond. Therefore, only correct answer is covalent bond is B. The blank has lower electronegativity than blank. You can see metals have lower electronegativity. I have shown you in the periodic table than non-metals. Therefore, correct answer is this. All other statements are not correct. Therefore, answer is the metals have lower electronegativity than non-metals. A. Which of the following pairs of atoms is most likely to form an ionic compound? Like I said before, metals and non-metals. Sulfur is a non-metal. Oxygen is a non-metal. That doesn't form ionic bond. Potassium is a metal. Chlorine is metal. That is the correct answer. Chlorine and nitrogen are non-metals, therefore this is not forming ionic bond. Sodium and calcium are two metals. They make metallic compound, alloys. Therefore, that's not the answer. Answer is B. In bonding, main group's elements gain loose share electrons to attain octet or electronic configuration of noble gas. Electronic configuration is the best answer. Which of the following occurs when an ionic bond is formed? Electrons are transferred from more electronegative atom to less electronegative atom. That's wrong. False statement. It normally takes place. Electrons are transferred from less electronegative atom. Greater electronegativity, gain electrons. Lower electron, lose. That is when an ionic bond is formed. That's a true statement. Electrons are shared equally. That is a non-polar covalent bond between 0 and 0.5. Ionic bond is formed electronegativity greater than 1.9. This is still the B is the correct answer. Sharing electronegativity difference between 0.5 and 1.9 is the polar covalent bond. We shown you in the previous slide. So for this question, ionic bond is formed when the electronegativity is greater than 1.9. B is the correct answer. Under which of the following conditions is the bond between A and B considered to be ionic? A and B have same electronegativity. If that happens, electronegativity difference is 0. That's a non-polar covalent bond. When the difference between electronegativity atoms is 1, that's between 0.5 and 1.9. That value is in between this range. Therefore, covalent bond. So it's not the answer. If it is 1.5, it's a covalent bond, polar covalent bond is formed. 1.9, ionic bond. That's the correct answer. D is the correct answer. Ionic bond form between a metal on the left side of the periodic table and the non-metal on the right side of the periodic table. That is what we are looking for. Covalent bond formed between non-metal on the side of and the non-metal. Covalent bond form right, both non-metal. Non-metals are found on the right side of the periodic table. Therefore, answer is right. Electronegativity of elements in the periodic table. Which of the following states are generally true about the electronegativity trend in the period? Let's revise. Electronegativity increase this way. All right. Going bottom to top also increase. Bottom to on the left side increase. On a period, going across increase. Electronegativity decrease as moves from moves from left to decreases from, that's wrong. That's the other way. That increase. Decrease from top to bottom. That's true. This statement is true, but other statement is wrong. Therefore, total statement is untrue. Electronegativity decreases as move from left to right. That's not true. It increases. Same as this statement. And increase as move to a top to bottom. That's not right. Electronegativity as move from, that's correct statement. Decrease as move from top to bottom. That's correct. Increase from left to right, that's correct. Increase as we move from top to bottom. That's not incorrect. That's not correct. Incorrect. Therefore, answer is only C. What types of elements generally have a high electronegativity? Non-metals. Non-metals, these are all metals. Transition metal, alkali metals. Rare earths are lanthanide and actinides. Halogens are non-metals. Therefore, answer for question 21 is D. Now I'm going to look into naming cations. We talked about that. We will go through this. Metallic elements are mostly found on group 1A, 3A, 2A, 3A. They make positive ions, positive 2, positive 3. The name of a cation is the name of the metal followed by ion. For example, sodium is name of the sodium ion. Name of the cation for same metal. The charge is fixed. They have these 1A, 2A, 3A has fixed charges. 1A always have positive 1. 2A has positive 2. 3A has positive 3. So these are the names of cations that are commonly found. Hydrogen ion, name of the element with ion, word ion. Magnesium ion, we don't call it 2+ ion. For main group elements, you just say the metal name and the ion. You should know aluminum is 3 plus because aluminum is 3A group, therefore it should lose 3 electrons. Calcium is in the 2A. Lithium is in the 1A, loses 1 electron. Strontium is in the 2A, loses 2 electrons. It's called strontium ion. Potassium ion is potassium plus. Naming anions is different from naming cations. If chlorine gains the electron to make chloride ion, chlorine is this. You add an I to the element name and call it chloride. Oxygen with true electrons form oxide ion, 2 minus. So hydride ion, I is used. Hydrogen iodide, hydride. Fluorine, you drop the in part. Let's talk about fluorine. You drop this part, in part, and add a I part. Chlorine become chloride, fluorine become fluoride, boron become bromide, bromine become bromide, iodine become iodide. Therefore, naming cations and anions are explained now here. Metals are the metals name plus ion. Chloride and anions are called metal names adding the prefix I. Prefix is the ending name here, I. Which of the following atom is the least likely to form an anion? An ion. Ion is a positively charged or negatively charged. Therefore, chlorine can gain an electron. Potassium can lose the electron. Iron can lose the electron. Most least likely to gain to form an ion is noble gas. This makes negative ion. Potassium makes positive ions. Iron makes either +1 or +3. They have variable charges. Transition metal. Iron is in the transition metal. Therefore, answer is noble gas are least likely to react. Therefore, they will not form ions. Which of the following elements is most likely to lose electron to become that should be the metal. So argon is a noble gas. It doesn't do anything. Sulfur is a non-metal. Iodine is non-metal. Therefore, answer is magnesium make. That is the answer. Which of the following element is most likely to gain or become an ion? So we are looking for non-metal. This is noble gas. This Ng means noble gas. Semi-metal. This is the one likely to. This is the non-metal. This is the metal. To become an ion, therefore answer should be C. Which of the following occurs when calcium is converted to calcium 2+? plus it loses 2 electrons. Calcium loses two electrons. Become calcium 2 plus 2 electrons. Calcium gains 2 electrons. No, not gaining. Protons are never changed in chemical reaction. So therefore only electron change. Again, this is the correct answer. 2 electrons. Calcium atom loses 2 electrons and 2 protons. They never lose 2 protons. Calcium atom loses 2 electrons. That's the correct answer. Gain is wrong. Calcium is a non-metal. Metal never gains. So answer is D. Now there are ions. We talked about monoatomic ions, metal ions, magnesium, calcium, sodium, or monoatomic oxide, chloride, bromide, etc. There are list of names of different polyatomic ions. Polyatomic means they contain more than, there's a typo here. That's the ammonium ion. Ammonium ion is the only polyatomic ion with a positive charge here. Rest of the polyatomic ions have negative charges. You need to remember this. What is hydroxide? This has 2 atoms. We also call polyatomic hydroxide. Nitrite, ite. If you have 3 oxygens, it's called nitrate. Acetate. This or that. This shows part of the structure of acetate ion. Perchlorate is ClO4 negative. Cyanide is Cn negative. Permanganate is negative 1. Chromate is negative 2. Dichromate, that's a 2 is a superscript. That's dichromate. Hydrogen carbonate or bicarbonate is that polyatomic an ion, polyatomic anion here. Sulfide, hydro bisulfate, hydrogen sulfide. Sulfate ion is SO4 negative. Hydrogen sulfate or bisulfate. This is when you have 3 oxygen is ite. When you have 4 oxygens, more oxygens is 8. Phosphate also have hydrogen phosphate and dihydrogen phosphate. Now, these are the ions, anions, mainly anions, that can form a polyatomic with other cations. So these are complex anions, polyatomic anions. What is the charge of the ion formed from group 7A? It gains 1 electron. Number of valence electron is 7. Therefore, it's a non-metal gain. 1 electron is. This is the correct answer. Gain of electron, 1 electron. Answer is C. What is the charge on the ion in the compound? Normally, oxygen is 2 minus. There are 3 of them. That's 6 minus. 3 times 3 is 6. Therefore, this should balance out that with a positive 6. Each one has positive 3 times 2. That is the part. Iron atom is 3 plus. So therefore, ion charge on the ion should be 3 plus. Which of the following ionic compound contains cations with positive? This is group 1A. Group 1A is this. This is not group 1A. That's group 2A. That's 2A. I think that's group 3A. You can go. That's the 1A. So 1A forms. So therefore answer should be A. I'm going to stop the class for today. You guys sign up the chat box. Are you guys still there?
Yes.
Okay, I will see you on next Thursday. All right?
Okay, goodbye.
Okay, I will see you then. Bye-bye.